A disk speed up from rest at a constant rate of 2.5 radians per second square. We are to find final angular speed of disk after 18 second. Number of revolutions that the disk will go through in this time of period. Then find a linear speed with a given radius is 50 centimeters. Remember to convert that radius to meters, so this 50 centimeters will be 0.5 meters. Then first thing first. For first question. The statement indicates that the disk speeds up from rest, which tells us more about initial angular velocity. That rest means that initial angular velocity is 0. So if we may list the data we have and match them with one of angular formula. When we are looking at formulas, the first one is completely out. Let us check the second one, unknown final angular velocity. We have initial angular velocity, acceleration and time. This one match the requirements. Only one unknown, that is final angular velocity, and that is the one we are looking for. We say final angular velocity equals 0 plus 2.5 times 18. That is giving us final angular velocity to be 45 radians per second. Now we are to find number of revolutions. We will use this equation, where we will be calculating the angular displacement and convert it from radians to revolutions. Angular displacement equals 0 plus half times 2.5 times 18 square. Remember, that 0, it is because of initial angular velocity is 0. We get angular displacement is 405 radians. Then we say 405 radians times 1 revolution per 2 pi radian. That give us number of revolutions to be 64.46 revolutions. This 1 revolution per 2 pi radians, it is a conversion factor for radians and revolution. Now we find linear speed. We use this equation. We say final linear speed is equal to 45 times 0.5. We get final linear speed to be 22.5 meter per second.